the one that you posted for exam 1, and then.
But all the limits exist.
So limits always exist.
No.
But
we didn't really discuss those that don't exist.
So on the test, they'll all be that they exist.
I think that would be safe to say.
Okay.
Because limits get covered in great detail in calculus. It's actually that's a calculus concept that we introduce in pre-calculus. Okay. But let me give you an example. Okay. So let's say we have the limit as x approaches. Now I'm making this up off the top of my head, so bear with me. Okay. X squared minus 1 over x minus 1. Okay. Now, the first step is do the direct substitution. Right? So you put 1 in for x, you have 1 squared minus 1 over 1 minus 1, and that's 0 over 0.
So
0 divided by 0 is undefined. Okay? But the limit may still exist. Okay? And so when you do the direct substitution, you get 1 over, or do the direct substitution, you get 0 over 0. That's when you want to factor the numerator and denominator. Okay? In this case. So this is equal to the limit as x approaches 1 of x minus 1 times x plus 1 over x minus 1. Well, x minus 1 is a common factor in the numerator and denominator. They cancel, and we're left with x plus 1. Now you do the direct substitution, and you have 1 plus 1, which is equal to 2. So even though the function is undefined at x equals 1, the limit still exists. Now, an example where a limit doesn't exist. The limit as x approaches 1 of x plus 1 over x minus 1. Okay? When you put 1 in for x, in direct substitution, you have 1 plus 1 over 1 minus 1, which is 2 over 0. That's not 0 over 0 form, that's 2 divided by 0. And when you have 0 in the denominator, but it's non-zero in the numerator, does not exist. Okay. Yes, ma'am.
Can you do this piecewise function from quiz 8?
Quiz number 8. I have that with me.
Okay.
Let me pull that up. Is there anybody here who hasn't gotten all their papers back? All right, problem number 1.
Yeah. It's just the graph validation.
Oh, okay. So we have f of x is equal to 2x minus 1, 2x plus 1. So fx is 2x minus 1 if x is less than or equal to negative 3. It's equal to 2x if x is greater than negative 3, but less than or equal to plus 3. And it's equal to 2x plus 1 if x is greater than 3, right? And I had you evaluate the function at different values of x, and that was to help you with the graphing, right? So f of 0 is 0. f of 3 is 6, f of minus 4 is -9, and f of minus 3 is -7, and f of 4 is equal to 9, right? So f of 0 equals 0 means the point 0, 0 is on the graph, right? That's the origin. And f of 3 equals 6 means the point 3, 6
I moved up, I can't see it.
Can't
Got
see,
my glasses
okay.
up. I'm sorry.
is on the graph. And then f of minus 4 equals -9 means minus 4 minus 9 is on the graph. F of minus 3 equals -7 means the point -3 minus 7 is on the graph. And we have the point 49 is on the graph. Okay. So I provided you with a grid. Here's the x and y axis, okay? Now, I'm just gonna plot the pertinent x and y points on the axes, okay? So here's the origin, okay, 0, 0. And then, let's see, I need 6, 7, and 9. So here's 6, here's 7, here's 9. And then I need -6, -7, -9. So here's -6, -7, -9. And then on the x-axis, I need, 3 and 4. So here's 3, here's 4, and here's -3. And here's -4. Okay. So, this won't be drawn to scale, but we'll get a good idea. Okay. And now we got to graph this function. Okay. So the easy part is this first part, x less than or equal to -3. Okay. So for x less than or equal to -3, right? This is the equation of a straight line, the slope 2. Okay. And so here's the point -3, -7 is right here. And you know, to draw a straight line, you only need 2 points on the graph. So -4, -9, right, is on the graph. So here's -9, here's like -4. And so this first part, f of x equals 2x minus 1 for x less than or equal to -3, right, is this half line going down and to the left. Okay?
And why is the circle filled in?
Because it's on the graph.
Okay, I thought that you could have an open circle on like these lines.
Open circle means that point's not on the graph.
Okay.
Open circle, not on the graph.
It's because those are the ones that are with the top one that has greater than or equal to.
Oh, okay.
Okay.
Thank you.
So this is x less than or equal to -3. So the point -3, -7 is on the graph. And that's the right end of this half line. Okay. Now, what might be easier than is to graph the last point for x greater than 3. Okay. For x greater than 3, right, the graph is a half line, right? This is a straight line, okay, with slope 2. But, so here's x equals 3, and for this last part of the graph, at x equals 3, we're gonna have an open circle, okay? At x equals 3. So to find the y coordinate for that open circle at x equals 3, we just put 3 in for x over here. And so you have 2 times 3 plus 1, which is 7.
Wait, wouldn't you just use, like the points like with the other ones?
Okay? We're going to,
Okay.
but we're graphing this last part for x greater than 3.
Okay.
Okay? So I guess we could plot this point, it makes you feel better. F of 4, right? The 0.49. So here's the 0.49. And we have a half line, right, that goes up and to the right for x greater than 3, right? So this half line comes down to x equals 3. There's an open circle at x equals 3, and to find the y coordinate of the open circle, you put in 3 for x, and you have 2 times 3 plus 1, which is 7. And so at the 0.37, there is an open circle. So this is the graph of the function for x greater than 3. Okay? It's a half line going up and to the right. And it begins to the right, immediately to the right of x equals 3. Okay? Then we have the middle part of the graph that goes for x strictly greater than minus 3 and less than or equal to plus 3. So at x equals 3, f of 3 is equal to 6. So the 0.36 is on the graph. So here's the 0.36. And this segment of the graph, right, includes all values of x greater than minus 3, less than or equal to plus 3. So that includes the origin. So this part of the graph goes through the origin. But it stops at x, the graph goes down through the origin, but stops at x equals minus 3. But it did just before you get to x equals minus 3. It doesn't include x equals minus 3. So there's going to be an open circle at x equals minus 3. What's the y coordinate for that open circle? You put in minus 3 in for x here, and you get 2 times minus 3, which is minus 6. So there's an open circle at the point minus 3, minus 6. And this is how the graph. These are all supposed to be straight line segments, but I'm doing this by hand. Okay. So the first part of the graph is for x less than or equal to minus 3. So it begins, right? So we have a closed circle, x equals minus 3 here, and the graph goes down and to the left. The middle part of the graph is for x greater than minus 3 and less than or equal to plus 3. So we have a closed circle here at x equals plus 3, but an open circle here at x equals minus 3. Okay? Because this point is not on the graph. At x equals minus 3, it's this point that is on the graph. And then for x greater than 3, we have an open circle here at x equals 3 because this point is not on the graph, but all the points to the right of it on the graph. Okay.
We also do the domain and that showed me up a little bit.
Okay. The domain. So you put all 3 of these intervals together, and you get all real numbers. And looking at the graph, you can see that the domain to x coordinates are real numbers, right?
Yeah. And the range is also,
The range is the y coordinates, right? So starting at the bottom, this goes down forever. So it starts at minus infinity. And then, as you come up, this point closer right here has a y coordinate of -7. And then the next y coordinate is greater than -6, right? This open circle's not on the graph, and its y coordinate's -6, so we have parentheses, -6. And then the y coordinates are everything up to +6, right, for this segment of the graph. And then on this segment of the graph, the y coordinates are greater than 7. They don't include 7 because of the open circle. They're greater than 7. And that's how we get the range. Okay. Yes, ma'am.
Can I ask a question not related to this?
Are you
yeah, that's all good.
okay?
Okay, on one of the reviews from exam 1, it says to simplify the rational expression. Can we work through it on the
Yep.
board?
Yep. What's the rational expression?
So it's x to the 5th plus 2x to the 4th power plus x cubed over x to the 4th power minus 2x squared plus 1.
Simplify that, right?
Yes.
Well, in the numerator, we have 3 terms, all involving the variable x, right? All involving the variable x. And the lowest power of x is x cubed, so we can factor out an x cubed in the numerator. When we factor out an x cubed, we're left with x squared plus 2x plus 1 in parentheses. And then in the denominator, this actually factors into x squared minus 1 times x squared minus 1. Now, in parentheses in the numerator, that factors into x plus 1 times x plus 1. In the denominator, each of these x squared minus 1s factor into x minus 1 times x plus 1, right? X squared minus 1 is a difference of squares. It factors into x minus 1 times x plus 1. See any common factors in the numerator and denominator? X plus 1, x plus 1. And so we're left with x cubed over x minus 1 squared.
Okay, and so like the second part, it's like I understand, but I'm just double checking. It says to find the limit, and then it gives us the limit, but do we do that from the original equation, or do we use the simplified one to
What's the limit?
-1?
Limit as x goes to -1.
Mm-hmm.
So you can see from factored form here, right? So this is equal to this, and minus 1 in for x here, right? You're going to get 0 in the numerator, because minus 1 plus 1 is 0. And you're going to get 0 in the denominator, it's minus 1 plus 1, 0. So you're going to end up with 0 over 0 form. So you have to cancel out all the common factors in the numerator and denominator, and then do the direct substitution.
Okay.
So you end up with taking the limit as x goes to minus 1 of x cubed over x minus 1 squared. And then you have minus 1 cubed over minus 1 squared, which is what? Minus 1 over minus 2 squared, which is equal to minus 1/4. Good stuff, Phoebe?
Diet Coke? Yeah.
All right. Yes, ma'am.
Can I ask a new question?
So, Courtney, did you get your?
Yes.
An angle,
In what?
the co-terminal stuff.
Okay.
So, for in this example from quiz 15.
Quiz 15, which I have. Okay. Which
Either
question 2 or?
either 2 or 3, or both.
Yeah. So in 2, you gotta find an angle that is coterminal with 5 pi over 12, right? 5 pi over 12 radians. Well, 2 angles are coterminal if they differ by an integer multiple of 2 pi radians, right? So when we were solving the trigonometric equations, we were representing that with 2k pi, right? And we added 2k pi.
Right.
So to find an angle that's coterminal with 5 pi over 12, we can just add 2 pi radians to it. Okay. The common denominator is 12. So when I multiply 2 pi, top and bottom, by 12.
So we can use that, do that for any, find any coterminal?
Yeah, and just add 2 pi, right? So given an angle in radians, find an angle that's coterminal with it, just add 2 pi radians to it. Oops, I did that wrong.
I think you just left off the 1 and the 12.
No. Yeah, 24 divided by 12 is 2, right?
Right.
And so, now you're just adding 2 fractions, the same denominator. 5 pi plus 24 pi is 29 pi. So the angle 29 pi over 12 radians is coterminal with 5 pi over 12 radians.
And,
Oh, I'm not done.
Okay.
Okay. Now, we could have also found the coterminal angle by subtracting 2 pi. Okay? You don't have to add, you can subtract. And so subtracting 2 pi is the same as subtracting 24 pi over 12. And 5 pi minus 24 pi is minus 19 pi. So minus 19 pi over 12 radians is also coterminal with 1 pi over 12. Okay. You can add an integer multiple of 2 pi, or you can subtract an integer multiple of 2 pi to get a coterminal. Okay. Now we didn't have to do 2 pi, we could have done 4 pi, or 6 pi, or 8 pi, or 10 pi, right? Those are all integer multiples of 2 pi. But 2 pi is a lot easier than 10 pi usually. Alright,
It's kind of like,
is your question
Mine's
related?
it's completely unrelated.
Okay.
so you don't have to do number 3, but like if it's giving you a degrees, would you just add 360 to it?
Or subtract 360?
Okay.
Could you go over how to sketch the absolute value of function? So like I have an example from
Okay. Give me the example, because that's easier than me making one up off the
Okay.
top of my head.
Is it from one of the exams?
Yeah, it's exam 2 review, I think.
Okay, what's the function?
F of x equals the absolute value of x squared minus 2.
Okay. So,
It also asks to find the x and y intercepts, or like label them.
okay. So, first thing I want to do is graph the equation y equals x squared minus 2. Okay? What's the graph of this going to be? Parabola, right? And we know what the graph of y equals x squared is, right? It's a parabola that goes through the origin, right? So the graph of y equals x squared minus 2 is the graph of y equals x squared shifted how? Down 2 units, right? So the vertex goes down, and then it's going to cross the x-axis, and we're going to have x-intercepts, right? So the graph of y equals x squared minus 2 the vertex is going to be at y equals minus 2 now, right? Actually, I don't want to draw that here. Let's draw it over here. So here's y equals minus 2, okay? And now the parabola, right, it still opens up. And it's symmetric to the y-axis, right? Parabola is symmetric to the y-axis. Here's the origin. So here's the y equals minus 2. And now it crosses the x-axis in these two locations. So this is the graph of y equals x squared minus 2. And you know how to find the x-intercepts. You set y equal to 0, solve for x, right? So we have 0 is equal to x squared minus 2, or x squared is equal to plus 2, right? You add 2 to both sides. And then you take the square root of both sides and get x is equal to plus or minus the square root of 2, right? So this is square root of 2 on the x-axis. This is minus square root of 2 on the x-axis, right? So now we know the x-intercepts, right? Now the graph, the absolute value of x squared minus 2, everything that is below the x-axis gets flipped over above the x-axis. Okay? So here's square root of 2 on the x-axis. Here's minus square root of 2. Okay. So the graph to the right is square root of 2. It's still going to go up. The graph to the left of minus square root of 2, it's still gonna go up, okay? It's the part that's below the x-axis that gets flipped over. And so this point down here at minus 2 is now gonna be up here at plus 2. Okay. So here's plus 2. And so the graph is sort of gonna be like a upside down parabola, right? Between square root of minus 2 and plus 2. And that's what it looks like. This is the graph of y equals the absolute value of x squared minus 2. I guess here we were doing a function, so we could say f of x, right? Does that sound?
Yes, thank you.
Yeah.
I was wondering, can we, solve, question 14 on exam 1 review, which is about finding the domain of this function, but
Okay.
it's complex, so.
So exam 1 review, question 14. What's the function?
F of x is equal to x minus 16 over 2x squared plus x minus 1.
Okay. So this is actually a rational function, right? Degree 1 in numerator, degree 2 in denominator. Okay. And so the domain is all real numbers. Remember, domain are the x coordinate, right? The numbers you can put in for x. And the right-hand side will equal a real number. Okay. So the domain is all real numbers except for those numbers that you put in for x in the denominator to make the denominator equal 0. Because if the denominator equals 0, that's undefined. The function's undefined, right? You can't divide by 0. So you can set up the domain, write out the domain as the denominator can't equal 0. Which means what can x equal? Okay. So factor the left-hand side. And the left-hand side factors into, I think, 2x minus 1 times x plus 1.
Yeah.
2x squared minus 1, 2x minus 1 x, right? So 2x minus 1 can equal 0, and x plus 1 can equal 0. Because if either of those factors equal 0, right, then the left-hand side will equal 0. Then it can equal 0. Now when you solve this equation, you get x can equal 1/2. And we solve this one, you get x can equal -1. So the domain of this rational function is all real numbers except for -1 and 1/2. So how do we write that in interval notation? Minus infinity to -1 union -1 to 1/2 union 1/2 to infinity.
Okay.
Yes, ma'am.
Could you go over,
Courtney, did that answer your
yeah.
question?
section 4.3, like the sketching of one cycle of the graph?
7.3,
4.3,
4.3.
on the final exam review?
Alright, so, do you have a function?
Yeah, f of x equals 3 sine,
3 times the sine.
of 2x minus pi.
Okay. So, that's a transform sine function. So we know what the graph of y equals sine x equals, right? So one cycle of it starting at x equals 0. And what's the period of the sine function? What's the period? 2 pi, right? Cosine, sine both have a period of 2 pi radians, right? So here's 2 pi, and in the middle is pi. Then we got pi over 2, and we got pi. Okay? Or excuse me, 3 pi over 2. So the graph so here's like y equals 1, y equals minus 1. Alright, so at pi over 2, sine equals 1. At pi, it equals 0. At 3 pi over 2, it equals minus 1. At 2 pi, it equals 0. Right? So here is one cycle which is another word for one period of the sine graph of the sine function, right? So the graph of this sine function, okay, is a transformation of the graph of this sine function. Okay. And the transformation is, right, because it's plus 3 up front, it's going to get stretched vertically. Because x is replaced with 2x, it's going to get compressed horizontally by factor 1/2. And because of this minus pi, there's going to be a phase shift. It's going to get shifted to the right. So this graph is going to get stretched vertically, compressed horizontally, and shifted to the right. Okay? 3 transformations. Okay. All right. So A is equal to 3. B is equal to 2, and C is equal to minus pi. And so the amplitude which is the amount of stretching or compressing, is equal to 3. So we're going to have vertical stretch. And then the period, which is the length of one cycle, in the graph of this transformed sine function, is 2 pi over b. And b is equal to 2. And so the period is pi radians. Okay. So vertical compression or horizontal compression, right? From x equals 0, right? The cycle begins at x equals 0, but in this graph it ends at pi. So it's going to go up, come down, and come back up to the x-axis in that short range. Okay, that short length. And then the phase shift, the amount of the phase shift is equal to C over B. C is, C is minus pi, and B is 2. So this is negative, right? So this is like x minus pi over 2, which means it's going to get shifted to the right. That many units, right? So it's going to get shifted to the right, pi over 2 radians, okay? And so here's pi over 2, okay? So the graph is going to get shifted to the right, pi over 2 radians, stretched vertically, okay, and compressed. Okay. All right. So whatever you do tomorrow, please don't draw 2 graphs on one graph. Draw one graph on the side and your final graph on the paper. Okay. So for the x coordinates, okay, without the phase shift, okay, they start at 0, and they end at pi, right? Are you with me? So for the graph of y equals 3 times the sine of 2x, okay, without a phase shift, okay, the x coordinates start at 0 and go to pi because the period is pi radians. And then you got to split this up into 4 intervals, right? You find the midpoint of 0 and pi is pi over 2. And the midpoint of 0 and pi over 2 is pi over 4. And the midpoint of pi over 2 and pi is 3 pi over 2. Okay?
3 pi over 4.
3 pi. I don't know why I keep doing pi over 4, pi over 2, 3 pi over 4. For some reason I keep doing that mistake. Yeah, it's 3 pi over 4. And so, without the phase shift, okay, the graph goes up, reaches its maximum here, comes down, reaches minimum here, and then back up again, right? It has the same shape as over here, only it does it in pi radians instead of 2 pi radians. Okay? Well, now we got to take this entire graph and shift it to the right. How many radians? Pi over 2 radians, right? So instead of starting at 0, it starts at pi over 2. Okay, and instead of ending at pi, it ends at 3 pi over 2. Okay, so we have the old x and we have the new x. The old x is 0, pi over 4, pi over 2, 3 pi over 4, and pi. The new x is the old, right? Old plus pi over 2 radians. So we have 0 plus pi over 2 is pi over 2. Pi over 4 plus pi over 2, which is 3 pi over 4. And then pi over 2 plus pi over 2 is pi. And then 3 pi over 4 plus pi is 7 pi over 4. And then pi plus pi is, I said, hold it, I messed up. Sorry. I get going so fast and then I copy this number and not this number. So 3 pi over 4 plus pi over 2 is 5 pi over 4. And then pi plus pi over 2 is 3 pi over 2. So we're incrementing. Okay. So instead of starting at 0, right, we're starting at pi over 2. Instead of ending at pi, we're ending at 3 pi over 2 because we got to add pi over 2 to all this. So the graph of our transformed sine function of f of x here here's 0. So we're increasing by pi over 4, right? So here's more pi over 4. So here's pi over 2. Here's 3 pi over 4. Here's pi. Here's 5 pi over 4. And here's 3 pi over 2. Right? Those are our 5 x coordinates, right? And so our graph says starting at the origin is going to start at pi over 2. right? Still gonna go up, come down, go up, but it's just gonna start at pi over 2 instead of 0. So, and it gets vertically stretched, so instead of the maximum value being +1, it's gonna be +3. So it starts here at pi over 2, and then at 3 pi over 4, its maximum value is +3, and then it comes back down, crosses the x-axis at pi, and then it comes down and reaches its minimum value at x equals 5 pi over 4, or its y coordinates -3, and then it comes back up here to the x-axis. So the graph looks like that. So it's the graph of sine x here. It's stretched by a factor of 3. It's compressed by a factor of 1/2, right? The period, right, from pi over 2 to 3 pi over 2 was just pi radians, right? Pi over 2 plus pi is 3 pi over 2, right? So the cycle, this is one cycle, and the period is equal to pi radians like we calculated here. And then the graph is shifted to the right pi over 2 radians. Because that's our phase shift. So doing the vertical, so like on the last exam, most people had no problem with the vertical stretch. Okay? And I'm guessing most people would have no problem with the horizontal compression. What it gives them, what will give them different is shifting the entire graph to the right. So tomorrow on the exam, you may have to draw this graph off to the side, and then draw this graph on the grid that you provided. Okay? I haven't, let me ask her, let her ask a question. You didn't ask
Okay,
me.
this is completely unrelated.
Wait, this is about this.
Okay.
You go first.
Why wouldn't you take the x coordinates that you like determine for the graph and then plug it in and do like the table with the x and then plug it in and then do x?
You could, I guess.
I just got a completely different thing when I did that. Like I got it going the other way. Like down first.
Well, you did a reflection across the x-axis there.
Okay.
Because this number out the front is positive.
Right.
So there should not be a reflection.
So
It
you
should go up first and then down.
so you could either do it this way or either make the table.
In fact, we did that in class.
Yeah, that's what
Yeah.
right.
But you should not have yours going down.
Okay.
You did some kind of reflection if you did that. All right, Vince.
Okay, so I have a question about finding the zeros, like real and complex.
Finding the what?
The zeros of something, like real
Of a
and complex.
polynomial?
Yeah,
Okay,
and I have one for you.
okay.
Let me know when you're ready.
Give me the function.
Okay. P of x equals 3 to the, x to the third minus 2x squared minus x plus 14.
And the question?
Find the zeros, real and complex.
Okay. Well, it's a third degree polynomial, which is odd, an odd degree, right? Complex, zeros come in pairs. So we're either gonna have 0 or 2 complex zeros. And irrational zeros also come in pairs. So we're either gonna have 0 or 2. So that means at least one 0 has to be a rational number. Okay, you know what rational numbers are, right? They're written as a fraction with an integer in the numerator, integer in the denominator. So we can write out the possible rational zeros, right, using the possible rational zeros test. And so the constant term is 14. The leading coefficient is +1, right? And so the possible, well, we need the factors, right? And so the factors, the integer, it's actually the integer factors of 14 are plus and minus 14, plus and minus 7, plus and minus 2, plus and minus 1, right?
Right.
And the factors of the leading coefficient are plus and minus 1. So when we divide all these factors of 14 by the factors of 1, we just end up with the factors of 14, right? So the possible rational zeros are these guys up here. Plus or minus 14, plus or minus 7, plus or minus 2, plus or minus 1. So one of those 8 numbers makes the right-hand side equal to 0. Which one is it? This is where it's just trial and error now. So you put in 1 in for x. P of 1 is equal to 1 minus 2 minus 1 plus 14, which is equal to 12. So 1 doesn't work. You put in minus 1 in for x. Minus 1 cubed is minus 1. Minus 1 squared is 1 times minus 2 is minus 2. Minus a minus 1 is plus 1, plus 14, which is equal to 15 minus 3, which is 12. So that didn't work, okay? So maybe we'll try 2. But hopefully we don't have to do all of these. P of 2, put in 2 in for x, you get 8 minus 8 minus 2 plus 14. And that's also equal. Why is everything equaling 12? 8 minus 8. Okay. And then P of minus 2 is equal to negative 8 minus 8 plus 2 plus 14. Voila! We found one, right? P of minus 2 cubed is negative 8. Minus 2 times minus 2 squared is negative 8. Minus a negative 2 is plus 2 plus 14. So you get minus 16 plus 16, which is 0. Okay? So x equals minus 2 is a 0, which means by the factor theorem, x plus 2 is a factor. Okay. So we can write to the right hand side is x plus 2 times the quadratic. Okay. So to find the quadratic, we can use synthetic division. Minus 2 goes in the box, and then the coefficients of the polynomial are 1 minus 2 minus 1, 14. So you know how to do synthetic division, right? Bring down the 1. Minus 2 times 1 is minus 2. Minus 2 is minus 4. Minus 2 times minus 4 is 8. Minus 1 plus 8 is 7. Minus 2 times 7 is minus 14. And 14 minus 14 is 0. And it's good that we got 0 because that's the remainder. And we would have to get that if x equals minus 2 is 0 and x plus 2 is a factor. If we got something else, something's amiss. Okay? So, these are the coefficients for the quotient. 1 goes with x squared. Minus 4 goes with x. 7 goes with 1. So, our polynomial, p of x, can be written as, it factors into x plus 2 times 1 times x squared minus 4 times x plus 7. Okay, are you with me? So now to find the last two zeros, we set the quadratic x squared minus 4x plus 7 equal to 0 and solve for x. So a is equal to 1, b is equal to minus 4, and c is equal to 7. And I do believe we're going to have some complex zeros. So x, by the quadratic formula, right, is equal to negative b. So we have negative of negative 4 plus or minus the square root of b squared, which is minus 4 squared, minus 4 times a times c. A is 1, c is 7. Over 2 times a. So negative 4 is 4. And then the determinant, minus 4 squared is 16. So we have 16 minus 28, which is negative 12. Square root of minus 12. Oh, I did 2 times a. I literally wrote that out. That should be 2 times 1. Okay, sorry about that. Well, square root of minus 12 reduces, right? Minus 12 is equal to 4 times 3, right, times minus 1. So square root of 4 is 2, square root of minus 1 is I. So we have 4 plus or minus 2y times the square root of 3 over 2. So x is equal to 4 over 2 plus or minus 2i times the square root of 3 over 2. Well, 4 over 2 is 2. And then these 2's cancel. And we're left with plus or minus I times the square root of 3. So Did it ask for the zeros and the complete factorization?
No,
What did it ask for?
just the zeros.
Just the zeros, right? So, the zeros, then, are the x equals minus 2, right? The first one we found. And then x equals 2 plus I times the square root of 3. And x equals 2 minus I times the square root of 3. Alright, so there's, man, there are a bunch. So let me ask, who hasn't asked a question yet? Keep your hand up if you have not asked a question yet. So, boy, all of a sudden everybody's, so let's start with you.
Alright, so it's sketching a graph of a polynomial function and to include n behavior, all intercepts, n behavior near x-intercepts. So do you want me to give you the function?
Yeah.
Alright,
Let me-
Where is this from?
exam review 3.
Exam review 3,
Yeah, number 16.
and what's the function?
F of x equals negative 2x times x plus 3 squared.
X plus 3 quantity squared.
Yeah,
So this is a multiplicity of 2.
okay.
Yeah.
Yeah, and then times x minus 4 with a multiplicity of 3.
That's it?
Yeah,
And that's from the, which exam review?
exam review 3.
Which problem?
16.
16. Okay. And so, what is it that we're asked to do?
Sketch the graph of the polynomial function and include n behavior, all intercepts, and n behavior near the x-intercepts.
Okay. In behavior, x-intercept, behavior at the x-intercept.
Yeah, and we have to sketch the graph.
So, the degree of this polynomial n, the degree n, you get the degree by adding the multiplicities. So, x is the multiplicity of 1, then we have x plus 3, right? You're just adding the exponents. So the degree is 1 plus 2 plus 3, which is 6, right? Which is even. The leading coefficient is the minus 2 out here, okay? Which is negative. Which is a negative number. Right? So the leading term, if we were to multiply this out and write out the polynomial in unfactored form, the leading term would be the leading coefficient minus 2 times x to the 6th power. So when the leading coefficient is negative and the degree of the polynomial is even, the left end goes down, the right end goes down. Both ends go down. So now we know what the end behavior is in the graph of this polynomial. Okay, yeah.
Is there a way that we can like read that out and know the end behavior rather than just like memorizing that, like the coefficient's negative, therefore?
But you pretty much got to do it this way.
Okay.
Yeah. Okay. All right. Because the leading term of a polynomial determines the end behavior. Okay. And so you got to know what happens under the different scenarios of the leading term. Okay. All right. So now we got to find out what the x-intercepts are. Well, the x-intercepts are the values of x that make the right-hand side equal to 0. So remember, these are factors, And so by the zero product property, either x can equal 0, or x plus 3 squared can equal 0, or x minus 4 cubed can equal 0. Okay. Well, x equals 0, right? That's a 0. Okay. And it has a multiplicity of 1. Which is odd. 1 is an odd number, which means the graph crosses at x equals 0, crosses the x-axis. That's what they mean by behavior. At the x-intercepts, right? Multiplicity of 1, odd, so graph crosses x-axis at x equals 0, okay? When I solve this one, x plus 3 squared equals 0 for x, I just get x is equal to negative 3. Right? Minus 3 plus 3 is 0, right? 0 squared is 0. You know, you can take the square root of both sides and then subtract 3, and you get x is equal to minus 3. And so x equals minus 3 is a 0 with multiplicity 2. That is an even number. 2 is an even number. So the graph at x equals minus 3, right on the x-axis, touches and turns. And then when I solve this equation for x, take the cube root of both sides and add 4, I get x is equal to 4. Remember, the zeros and the x-intercepts, right, were the zeros, right? The 0 and x-intercept, location of the x-intercept. Okay? Well, x equals 4 is a 0 with multiplicity 3, and 3 is an odd number, so the graph crosses the x-axis at x equals 4, or at x equals 4. And now, you might have been provided with a grid. I'm going to draw one. So the x-intercepts are at x equals 0, x equals minus 3, and x equals 4. Okay? And we know that in behavior, the graph goes down on the left, and it goes down on the right. Okay? So at x equals minus 3, x equals minus 3 is the 0 of multiplicity 2, and we know the graph touches and turns, so as we go from left to right, it's got to come up here and touch the x-axis at minus 3, and then turn. It doesn't cross. Okay? So, graph has to come up, touch the x-axis at minus 3, and then turn. Okay? At x equals 0, we know the graph crosses the x-axis. So it's got to form a turning point between minus 3 and 0, and then cross at the origin. At x equals 4, the multiplicity is odd, so the graph has to form a turning point and then cross the x-axis and then hook up with it going down to the right. And so it's all deductive reasoning. Okay. And that's the graph. Okay. Alright, now you've asked questions. Who hasn't asked a question yet? Okay. So Mr. Patel, well,
Relate angle A to angle B and sides A and B with A equals 110, A equals 11, and B equals 5.
Is that also a B?
Yeah.
alright, say that again.
Relate angle A to angle B and sides small a and small b if big A is 110, small a is 11, and small b is 5.
So small b is 5.
Yeah.
And small a is
11.
11?
Yeah.
And we're relating angle B.
Angle big A to angle big B.
And which one is 110 degrees?
Big A.
Okay, so we're relating angle B to angle A. And side A and side B.
The question just words it as relate angle A to angle B.
Relate angle A to angle B. Do you have it?
It's on the
Maybe
bottom.
it's poorly worded. Okay. So, I guess it should be worded the other way. It would make more sense if it were worded the other way. Relate angle B to angle A. Okay. It should be worded relate angle B to angle A. So, by the law of sines, the sine of angle B over side B is equal to the sine of angle A over side A. So B is equal, side B is equal to 5. Angle A is 110 degrees. And side A is 11. And now if you multiply both sides by 5, you get the sine of angle B is equal to 5 times the sine of 110 degrees over 11. And that's the relationship. Okay, stops right there. All right. Who hasn't asked me a question? In the back.
This is from exam review. It's 1, question 2. It's
It's what?
it's write the expression without the absolute value symbols.
Okay.
So the equation is the absolute value of x minus 2 plus the absolute value of x plus 7. And we're supposed to find the negative infinity sign to negative 8.
All right. For x in the interval from minus infinity
Yes.
to minus 8, right?
Mm-hmm.
All right. So this is where you use the definition of absolute value. And definition of absolute value says the absolute value of x is equal to x if x is greater than or equal to 0, and it's equal to minus x if x is less than 0. Okay? The absolute value makes a negative quantity positive, and it keeps a positive quantity positive, right? So, we're going to do the same thing with x minus 2 and x plus 7 for x in this interval right here. Okay? So if I replace x with x minus 2, in our definition of absolute value, I have absolute value of x minus 2 is equal to x minus 2 if x is greater than x minus 2 is greater than or equal to 0, and it's equal to the negative of x minus 2 if x minus 2 is less than 0. Okay? So you notice in our definition, right, the absolute value bars get dropped here, right? And over here, the absolute value bars get dropped. Well, x is less than negative 8, right? It's in the interval from minus infinity to minus 8, right? Which means x is less than negative 8. That's what that means. And if I subtract 2 from both sides, I have x minus 2 is less than negative 10. Well, negative 10 is less than 0. Right? So x minus 2 is less than 0. X minus 2 is less than 0, which means absolute value of x minus 2 is equal to the negative of x minus 2. That's how we get rid of the absolute value bars. So the absolute value of x minus 2 is equal to the negative of x minus 2. Because in this scenario, where x is less than negative 8, that means x minus 2 is less than negative 10, which is less than 0. And so absolute value of x minus 2 is equal to the negative of x minus 2 in this case, okay, in this scenario. Similarly, the definition of absolute value of x plus 7 is equal to x plus 7 if x plus 7 is greater than or equal to 0, and it's equal to the negative of x plus 7 if x plus 7 is less than 0. Well, we're given that x is less than negative 8. So if I add 7 to both sides, all right. So if we add 7 to both sides, if x plus 7 is less than negative 1, and negative 1 is less than 0, so that means the absolute value of x plus 7 is equal to the negative of x plus 7 under this scenario. So absolute value of x plus 7 is equal to minus x plus 7. And now we distribute the minus sign. And we have minus x plus 2 minus x minus 7, right? We distribute the minus sign there. Minus x is minus 2x, and 2 minus 7 is minus 5. And so that's how you rewrite that without absolute value bars. Right? Any questions on that? Connor, did you have a question?
quiz 9, section 2.9, number 2 says a rectangle has an area of 10 m squared, but x represents the width of the rectangle. Discuss the perimeter as a function of width x. How would I start with that equation?
Is this question number 1?
No, 2.
Alright, read the numbers again.
Alright, 10 m squared, but x represents the width of the rectangle.
Okay.
And it says also to express the perimeter as a function of the width x.
So this is quiz 9, question 2 of version 2 of the quiz. The rectangle has area 10 meters squared. So here's our rectangle. Ten meters squared is the area. X is the width of the rectangle. Express the perimeter as a function of the width x. Okay? So x is the width, y is the length, and we're given the area of the rectangle. Area is width times length. Well, the area is 10 meters squared. The width is x, the length is y. So the length y, written as a function of x, is equal to 10 over x. Right? Divide both sides by x, I get y is equal to 10 over x. So y is equal to 10 over x. And express the perimeter as a function of the width x. So the perimeter is just the distance around the outside of the rectangle, right? So we just add up these four sides, and we get the perimeter is equal to x plus 10 over x plus x plus 10 over x. X plus x is 2x, and 10 over x plus 10 over x is 20 over x. That is the perimeter as a function of x. Boy, it's a trip eating a menthol cough drop with a face mask on, because the menthol comes right up your face into your eyes. All right. Have you asked a question yet?
No.
Okay, sure.
It's section 4.5 on the exam study guide. It says if cosine x equals 5 over 8.
5/8?
Yeah.
Right. So cosine x is equal to 5/8.
And 3 pi over 2 is less than x, which is less than 2 pi. Find the exact value of cosine and sine 2x.
Okay. So, well, what quadrant is angle x in? Quadrant 4. And is cosine positive or negative in quadrant 4? Positive, and cosine x is equal to a positive number here, so it makes sense, right? So the easiest one to find is cosine 2x. Because one expression for cosine 2x is 2 times cosine x squared minus 1, if I remember correctly. Well, cosine x, remember this means 2 times the cosine of x squared minus 1. Cosine of x is 5/8. So 2 times 5/8 squared minus 1. 5/8 squared is 25/64. Two times 25/64 is 50/64. And minus 1 can be written as 64 over 64. And 50 minus 64 is negative 14. And we can reduce that. Cosine 2x is equal to 7/32 minus 7/32. Now, to find sine 2x, we need to know what cosine x is equal to. To find sine 2x, we need to know what sine x is equal to. So we got some work cut out for us. Well, in quadrant 4, is the sine function positive or negative? Yeah, so sine x is negative in quadrant 4. Well, to find sine x, we can use the Pythagorean identity. Cosine x squared plus sine x squared is equal to 1. So cosine x is 5/8, so cosine x squared, we actually already calculated over here, right? 5/8 squared is 25/64. We'll write it out again. 5/8 squared plus sine x squared is equal to 1. 5/8 squared is 25/64. Sine x squared is equal to 1 minus 25/64. 1 can be written as 64 over 64. And 64 minus 29 is
25.
what?
It's 25, right?
Minus 25. It's 39.
The what?
You said 64 minus 39 instead of 25.
64 minus 25. 64 minus 25 is 39. Correct? And then sine x is negative, so it's the negative square root of 39/64. which is equal to square root of 39 over 8. So, now we can calculate what the sine of 2x is. Sine of 2x is 2 times the sine of x times the cosine of x. Sine of x is minus square root of 39 over 8. And cosine of x is 5/8. Positive times a negative times a positive is negative. So 2 times 5 is 10. So we have 10 times the square root of 39 in the numerator. 8 times 8 is 64. And so 10 and 64 are both divisible by 2. So we have the sine of 2x is equal to 5 times the square root of 39 over 8.
Over 32.
Over 32. Getting tired. Alright, who hasn't asked a question? Your turn.
So this is on exam review 4, number 9. It says, initially 200 bacteria in a culture are present. It is observed after 7 years that the number of bacteria has doubled. Find an exponential model for the number of bacteria in the culture after 2 years.
Okay. So initially there are 200.
Yep.
And it doubles after how many years?
7 years.
So the model is going to be A of t is equal to 200. Well, k, the growth rate, is going to be the natural log of 2 over 7. Okay? That's the growth rate. And so A of t is equal to 200 times e to the kt power. K is natural log of 2 over 7 times t. Okay? Now what's the question?
Find an exponential model for the number of bacteria in the culture after 2 years.
That's it. That's right here.
And then the next question is, how long will it take to grow 700 bacteria?
700. Okay. So to find how long it takes for the number of bacteria to grow to 700, we replace A of t with 700. Right? And then we solve for t. So divide both sides by, remember this is 200 times e to this number. So we can divide both sides by 200. 200 cancels on the right. And then 700 over 200, 7 halves. So we have e raised to the natural log of 2 over 7 to the t power. T is in the exponent, right? So to get rid of the e, we take the natural log of both sides, right? So we have the natural log of, and if you wanna write 7/2 is 3.5, that's okay. So we have natural log of 7/2 is equal to natural log of e, natural log of 2 over 7 t power. So I'm gonna write 7/2 is 3.5. So I'm not writing a fraction over and over, right? 7 divided by 2 is 3.5. And I'm not rounding that number off, right? That's the exact value. And so on the right-hand side, we have natural log of 2 over 7 times t. So you multiply both sides by 7. 7 times the natural log of 3.5 is equal to the natural log of 2 times t. And now you divide both sides by the natural log of 2. And you have t. How long it's going to take for it to grow to 700 bacteria is 7 times the natural log of 3.5 over the natural log of 2.
I have a question kind of related to this.
Okay.
For K, if it's the half-life of it, what do you do to ln? Like to make it the half-life?
You can put a minus sign.
Okay.
Over the number of years to double. Or you can do the natural log of 0.5.
Okay, so both of them are an option to do.
Yeah, minus
Okay.
log to 2 and log 0.5 would give you the exact same decimal value on the calculator. Is there anybody who has not asked a question who wants to ask a question? Yes, ma'am.
I have a question on, I don't know what to explain it out loud.
Which one?
Just
Okay.
like how to do those
Okay.
really.
The logarithmic equation?
The rational. Oh wait, question, yeah, those.
5 or 6?
5.
Okay.
Just any of.
Okay. So this is question 5 from exam 4. So what I write on the board, you're given the left-hand side, and you gotta write the answer on the right-hand side. So,
You don't have to do all of them, but like just the example of one, like the ones I got wrong.
okay, so we have b raised to log, log base b of 5. And so, one of the properties of the logarithm says this is just equal to 5. Okay. Then we have e raised to the natural log of 6. Well, at natural exponential function, natural log function, and inverse functions of each other, this is just equal to 6. Now the next one's a little bit more interesting. We have e raised to the 1/2 times the natural log of 16 power. We can't cancel the e and the ln yet because of the 1/2 out front here. But the power rule says I can bring this 1/2 inside the natural log and make it an exponent of the number 16. So this is e raised to the natural log of 16 to the 1/2 power. A natural exponential function, natural log function are inverse functions of each other. And so this just simplifies to 16 to the 1/2 power. Anything raised to the 1/2 power means square root. And the square root of 16 is 4.
That's good, thank you.
Alright, anybody else not get to ask a question yet? Alright, so now accepting seconds on question. Yes, ma'am.
Number 7 on exam 3 review, it's, simplifying the difference quotient.
Okay. What's the function?
F of x equals x over x plus 4.
X over x plus 4.
Yeah, and then we have to find the difference quotient.
So f of x plus h, we just put x plus h in for x, right? And we have x plus h over x plus h plus 4, okay? Then step 2 is f of x plus h minus f of x f of x plus h is x plus h over x plus h plus 4, and then we're going to subtract f of x, which is x over x plus 4, right? And then we got to simplify, okay? So you're subtracting two fractions, you need a common denominator, right? What's the common denominator? X plus h plus 4 times x plus 4, right? So we're going to multiply top and bottom of this fraction by x plus 4. And top and bottom of this fraction by x plus h plus 4. Now we got to simplify, right? So we got to FOIL x plus h times x plus 4. Distribute minus x inside parentheses here. Okay? So when we do that, x times x is x squared. The outer 4 times x. Inner h times x. Last 4 times h. Now when we distribute the minus, this is minus x inside the parentheses here. We have minus x squared minus hx minus 4x over x plus h plus 4 times x plus 4. So we have some common terms in the numerator, x squared minus x squared, hx minus hx, 4x minus 4x. Now we're left with 4h. So f of x plus h minus f of x is equal to x plus h times x plus 4. You have 4h over x plus h plus 4 times x plus 4. And now we divide both sides by h. And dividing by h is the same as multiplying by 1 over h. And so when I multiply both sides by 1 over h, okay, so I have h in the denominator here, h in the denominator here, you see these h's cancel. And we're left with 4 over x plus h plus 4 times x plus 4. I've had enough, guys. My brain is fried.
Your brain's fried.
Yeah. Mine's a 63-year-old brain. Yours is nice and young. All right. So good luck tomorrow. I'll see you tomorrow.
10:30.
10:30.